Now that we examined how to approach solving absolute value inequalities and how to convert them to the appropriate compound inequalities, let's actually practice some solving. So first problem, we have the absolute value of 2x minus 11 is greater than 9. And I'm going to do the same thing I've done before. I'm not just going to read it like that. I'm also going to say it the way we should with the definition of absolute value. What this statement means, and again, we'll draw a picture for it. It means the distance at the expression 2x minus 11 is located on the number line is greater than 9 units away from 0. And so here's 0. Here's 9 units right over here to the right. Now, this tells me this expression, 2x minus 11, is greater than 9 units away, which means it would be located, well, you would use an open circle here, it would be located to the right of it. And so that means my expression, 2x minus 11, would be greater than 9 for that first part. But we also know if it's beyond 9 units from 0, it can go beyond negative 9 to the left. And so that means my expression 2x minus 11, open circle on negative 9, but it can go beyond 9 units. So it can go to the left as well. And so I want to show you visually how we can set up and see why we split absolute value inequalities into two compound inequalities. Into compound inequality is visually, it makes sense if you understand the definition. So what are my inequalities? They are 2x minus 11 is less than negative 9, or 2x minus 11 is greater than 9. And since it's an or compound equality, we can just solve them separately. I would add 11 to both sides. You get 2x is less than 2. I then would divide by 2 and get x is less than 1. Here I would add 11 to get 2x is greater than 20. Divided by 2 on both sides, x is greater than 10. And so if I were to look at this, and I'm going to write it above the graph as one compound inequality statement, it says x is less than 1, or x is greater than 10. And so let's put 1 here on the number line, and we'll put 10 here. We know that they are open circles, and we're greater than 10. So all the numbers that would be greater than 10. So to the right, we're less than 1, so all the numbers that are less than 1. And so we notice since it is greater than 9, this was an or compound inequality. Remember, mispronounced it great or, and it tells you it's an or compound inequality. And we just split it. And so to help me split it, I did one visual to show you the definition of absolute value. You could also kind of do this. You can just copy down the first one without the bars. And then, taking that whole mindset of, well, if you're dealing with absolute value, you're dealing with the positive and the negative of the number. So if I have positive 9, then I'm going to have negative 9. And since I dealt with the negative, I'm going to have to flip the inequality. That's another way to do it as well. So let's look at example 2. And so on this one, the absolute value 2x plus 5 minus 3 is less than or equal to 8. Well, we need to isolate our absolute value first. We can't do anything until it is all by itself. So I'm going to have to add 3. And that's going to give me the absolute value of 2x plus 5 is less than or equal to 11. And so what do we do here? Let's not just read it that way. Let's also read it by our definition of absolute value. This says that the expression 2x plus 5 is located, less than or equal to, so it's located within 11 units from 0. So I'm going to put 11 here. It's or equal to, so that would be a closed circle. Now it's located within 11 units, so that's inside to 0, so it's located in this amount. But we also know 11 units can go to the negative as well, to negative 11. So that means, again, closed circle, it can be within 11 units. So within this space right here. And so it can go over there. Well, this, again, mispronounce it. It is less than. It's an and compound inequality. And look at the way it's set up. Your variable expression, 2x plus 5 is what we have in the bars, is within 11 units of 0. And so that means it's less than or equal to 11, and it's greater than or equal to negative 11. And so by doing this picture, it allows me to actually come up with my compound inequality right away. Negative 11 is less than or equal to the expression 2x plus 5, which is less than or equal to 11. And so this is an and compound inequality. And we learned to solve this, whatever you would do to the middle, and that's where you need to focus, to isolate the variable, you would do to both outsides. So I would subtract 5 from the middle and then both outsides. So I get negative 16 is less than or equal to 2x, which is less than or equal to 6. Again, still focus, how would you isolate the middle? You would divide everything by 2. And I'm going to go ahead and write it here. That would give me negative 8 is less than or equal to x, which is less than or equal to 3. And so there's my compound inequality. So to graph it, we're going to do the same thing. We'll just put, negative 8 on the number line, our positive 3. We have closed circles for them because it is or equal to. And your x, visually, look, x is between these two numbers. So your solution is between those two numbers on the graph. And so there is our graph. So this was an example of a greater than, an example of a less than inequality with absolute values. The key is isolate it and split it apart. You can mispronounce greater to know or compound inequalities and less than to represent and compound inequalities. I find for many students who struggle, this visual technique, applying the definition, is helpful to assist with the process.